In this lab, management wants us to use a DHCP server to automatically provide IP addresses to one LAN network, while the router automatically provides IP addresses in the other LAN network. Specifically, management wants us to use the router server to provide IPs in the 192.168.10.0/24 network for LAN 1. And management wants us to use a DHCP server to provide IPs in the 192.168.20.0/24 network for LAN 2. DHCP stands for Dynamic Host Configuration Protocol. It is a way for devices to get IP addresses in other network settings automatically. Why is DHCP helpful? Without DHCP, network settings must be entered manually on each device. This takes a lot of time and effort. DHCP allows devices to get their IP address, subnet mask, gateway, and other settings dynamically when they connect to the network. This makes deploying new devices much easier. It also avoids address conflicts from, entering in the settings wrong. Because it's all automated, you don't touch it, it can avoid those address conflicts. But how does DHCP work? A DHCP server provides and manages IP addresses on a network. Client devices, like this laptop here, request and receive addresses from the DHCP server. Addresses are leased for a period of time until renewal. DHCP automates the address management as devices join and leave the network. So, for example, if you had an IP address of 192.168.10.11 and then you left the network, you took off your laptop, that IP address, once the lease is up, can be renewed by someone else. So if someone else came in, that IP address could be assigned to them. Routers or dedicated servers can run DHCP services to automate the network configurations. So this saves administrators substantial time and effort. In this case, we're using a router for DHCP for one network and are using a DHCP server for another network. So let's start with the router configurations. Console into the router using PC1. Now let's create the IP DHCP pool for LAN 1 with the command config-t to get into global config mode, then IP DHCP pool LAN-1 to name the DHCP pool and get into the DHCP pool configuration mode. Then the network for the pool of addresses that can be handed out, which is 192.168.10.0, 255.255.255.0. Next, we have to put in the default router for this network, which is the interface on our router connected to LAN 1, which is 192.168.10.1. Next, we could put in the domain name we want the host devices to get. So this domain name, what it does is it allows the devices to properly resolve host names using DNS. And management told us the DNS server is 192.168.50.2, so let's add that in as well. Perfect. Make sure to save your configuration. Now, how do we redirect LAN 2 DHCP requests to the DHCP server? We'll have to add a line to the router for the interface LAN 2 is connected to. That way, when a device is asked for the DHCP IP address, the interface will redirect them to the DHCP server. First, we need to get into the LAN 2 connected interface, which we can check with the show IP int brief command. Here we could see G01 is the interface that has default router IP for the LAN 20 network, which is 192.168.20.1. So let's go into the interface's configuration mode with the int G01 command. Then we need to forward the DHCP requests that come in through this interface to the DHCP server IP address, which is 192.168.30.2. The IP helper-address command tells the interface to forward the DHCP request to the DHCP server we have set up. Now, save your configuration file, save your packet tracer lab, and update your notes. On a DHCP server, we have to turn on the DHCP service, set up the pool name, then the default gateway, which for the 192.168.20.0/24 network is 192.168.20.1. After that, we have the DNS server, which management told us was 192.168.50.2. And since we know management told us that we need to exclude the first 10 IP addresses of the network from being handed out to the devices, we'll have the starting IP address as 192.168.20.11 with the subnet mask of 255.255.255.0. Then click Save and OK when the prompt tells you the new server pool name will be added. Notice that it automatically updates the max number of users. But it also changed our starting IP address. Change it back to .11 and save again. Now, open up the IP configuration settings on each PC and set them to DHCP. They should all succeed with PC 1 and 2 getting an IP from the router in the 192.168.10.0/24 network, and PC 3 and 4 getting an IP from the DNS server in the 192.168.20.0/24 network. If it fails the first time, try a second time. It might take a little bit for it to send the packets and the DHCP request through the packets and to get those packets back with the acknowledgement and the actual IP address. Awesome. You successfully set up DHCP on both the router and a DNS server. Now save your Packet Tracer Lab and update your notes. Remember to always write your narrative. After that, share the Google Drive folder you have for this lab with anyone with a link can organize, add, and edit access. Then submit the lab for review. If you don't know how to submit the lab, refer to the instructions in the lab's intro video section of this program. After that, you can move on to the next lab.